Hello again, and this is the last video for the first week's class and also for the first chapter of this course. So we are going to use the programming language R that we have learned in the R tutorial and the corresponding videos to practice some simple applications that we have learned in the combinatorial analysis chapter. So let's read the first question and let's see what we are going to learn. So it says in the programming language R, there is a built-in function called choose that calculates number of combinations. So remember, we were calculating the number of two-element subsets in a superset of size 4 as 4 choose 2, and this formulation expands as the 4 factorial divided by 2 factorial and 4 minus 2 factorial, so 2 factorial. Okay, so in general, if I have two arguments such as n and k is supposed to be at least less than or equal to n, and in this case we can calculate n choose k as n factorial divided by k factorial times n minus k factorial. Okay, now actually for small values such as 4 and 2 here, we can easily calculate the number of combinations by small algebraic operations. However, when n and k are comparatively large, in that case, the required calculation takes so much time. In fact, the values that you are going to compute can be infinitely large. Okay, so in that case, if you want to calculate such values for n and k values which are large, you need to use a software or a language to calculate such number of combinations. Now, let's practice how this choose command works in R. So I have opened my R session here, and to practice my commands, I'm just going to open a new script. And in the new script, I'm going to write my commands here. So let's try choose 4 and 2. This means we are going to calculate the number of two-element combinations in a superset of size 4. And if I select all of these comments and run it, I will see the result is 6. So this is basically, this choose function is basically the same as the number of combinations formulation. Okay, so here the parts of the question asks me to calculate the following combinations. So what is the number of 10 element subsets in a superset of size 30, or in other words, what is 30 choose 10? So what I'm going to do is I am just going to use this same function here, and I will say choose 30 and 10 here, and it is going to give me 30 choose 10 as a very large number, almost approximately equal to 30 million. Okay, another question is to determine 50 choose 15, and let's do that. Now, such number of combinations cannot be easily calculated, even if you have a calculator, a scientific calculator in your hand. That value is such a large number. You see, it says 2.25 times 10 to the power 12. So this is a scientific value, okay, scientific number, a very, very large number. Multiply 2.25 with 10 to the power 12. So this e plus 12 stands for 10 to the power 12. And we can also calculate other values such as 100 choose 40 or 1000 choose. So that's 100 choose 40, and I'm just going to calculate the next value, 1000 choose 100. So these two values can be run with Control R again. So you see we have 1.37 times 10 to the power 28 and 6.38 times 10 to the power 139. These values are very, very large numbers. I mean, even if you have a scientific calculator, it will not be very easy for you to calculate such values. a software or a programming language is definitely required to calculate such number of combinations. Now, in practice, can you come up with a question that requires such a number of combinations? Actually, yes. In practice, it is possible to come up. Now, it says, can you calculate all of the above combinations in a single command line? So what I'm going to do is, instead of calculating A, B, C, and D separately, I am going to define a single command line, choose, and in the first argument, I will create a vector, and in the second argument, I will create another vector, and in the first vector, I have the n values, 30, 50, 100, and 1000 respectively, and in the second element of the choose function, I will have another vector which stores the k values. So this is going to be 10, 15, 40, and 100. Okay, so I will have these values. Now, if I run this command in a single shot, all of the above 4 values will be seen as a result of this. So in this choose function that I have created, what we have is the number of combinations are calculated in a piecewise manner, just like a summation or subtraction operation. So the first indices are going to be used in a combination calculation. The second indices are used in a separate combination calculation, so on and so forth. Okay, so let's skip to the next question. It says, in how many different ways we can select a committee of 100 people among a population of 10,000 people or 1 million people? So this question cannot be answered with conventional ways. So you definitely need to use a software or a programming language. So for the first part of the question, I will simply say, choose. So we have 10,000 people and we are just going to choose 100 of them. And that is, you see, 6.5 times 10 to the power 241. And if you need to choose 100 people out of 1 million, then you need to write 1 million here, or you can simply write 10 to the power 6 in a shorter manner. So the value is going to be infinity. Okay, so in fact, this software, even this software, is not capable of calculating such a large value, such a large number. Okay, now we are going to define a function that calculates the multinomial coefficients that we have covered in the theoretical course. So remember, what was a multinomial coefficient? So assume that we have n objects, and we are going to divide these n objects into r different groups, such that in the first group there will be n1 objects, in the second group there will be n2 objects, so on and so forth. Finally, in the group there will be nr objects, and the summation of these n1, n2, n3, nr values is going to be equal to n. So basically, we are creating a grouping of these n objects into multiple subsets, okay, multiple groups. And this question, actually, in R, there is not a function that calculates these multinomial coefficient. Therefore, we are going to write it down by ourselves. Okay, we are going to define a multinomial coefficient function, and the name of this function will be mchoose, because simply the choose function was calculating the number of combinations, and mchoose function is going to calculate the multinomial coefficients. Okay, so we are going to define a function, R function, which is named as mchoose, and it computes a multinomial coefficient. And how it is going to do that? We are going to introduce the grouping sizes, and we do not need to introduce the n as an argument. Okay, why? Because n is automatically going to be equal to the sum of these grouping size. And we are just going to determine or introduce N1, N2, N3, the sizes of groups as an argument, and we can introduce in a set, and it is going to calculate the multinomial coefficient. So remember, what was the multinomial coefficient? For example, for 10 choose 2, 3, 5, we calculate this multinomial coefficient as 10 factorial divided by 2 factorial, 3 factorial, and 5 factorial multiplied with each other. Okay. Therefore, we are going to run this calculations in this mchoose command. So let me show you or explain it to you. So we say mchoose is a function that calculates the multinomial coefficient for an n vector. So we say nvec to understand that it is a vector. Okay. I mean, you can write anything else as well. I mean, you are not supposed to exactly write nvec. This is just the name of your argument. You can define it as you like. And I just choose to write it nvec, so I am not going to forget that it's a vector. And nvec is a vector that contains all these n1, n2, n3 values, group sizes. Okay. Now, after defining mchoose as a function which is going to use the argument nvec, I open my curly brackets, and inside the curly brackets, I write that are needed to be performed. And the first thing that I need to do is to determine the total number of objects. And the total number of objects is the summation of the elements in this n vector. So I write sum nvec as the total number of objects, which is n. And as a result, I'm going to define factorial n divided by the factorial values of each values in this nvec vector, and I multiply them with each other with a product command. So if you remember the R tutorial, prod function stands for product, and it calculates the product or multiplication of the elements of everything here. So let's run this command down to calculate 10 choose 2, 3, 5. So if I define this function and then I write mchoose, I introduce a vector here with elements 2, 3, and 5. Okay. Now, this single command is going to calculate the multinomial coefficient as 2520. Now, if you remember, this was exactly the question related to the police station in our theoretical course. Okay, so let me explain how this function does everything. So first of all, let me define this as the nvec. Okay, so when you introduce this argument as nvec here, it is going to be assumed as nvec in the function. So let's just say this is nvec. Okay, so my nvec is 2, 3, 5. First, it calculates n as the sum of nvec, and n is equal to 10. Then it calculates the factorial n, and factorial 10 is equal to 3,628,800. And then it calculates the factorial of nvec here. So the factorial values of 2, 3, and 5 are respectively 2, 6, and 120. And if you intend to calculate the product of these factorial values, you will get the product of these three values as 1,440. Basically, you are dividing this value to 1,440, and as you can see, if I run this command, I get 2,520 as the result. But this function does everything simply in a single line. Now, I can answer the rest of the questions. It says compute 100, choose 10, 20, 30, 40. So we have 100 objects. We are going to create groups of 10, 20, 30, and 40 into 4 groups. In how many different ways we can do that? So what I'm going to do is I am just going to copy this comment, but this time I'm just going to write Now, either I can write it like this, 10, 20, 30, and 40 like this. And if I do that, if I run this command, I will get the answer. But I'm going to do something else. I'm just going to say 1 to 4 integers of 1 to 4, and I'm going to multiply them with 10. Okay, so I guess this is a much more simple way to calculate a sequence of values starting from 10 to 40, and the step size is 10. Or you can write sequence starting from 10 to 40, and the step size is equal to 10. Okay, so in either way, you are going to get the number. So this function and this function is going to give you the same result. Okay, or you can write the combine function and you can simply write 10, 20, 30, 40, and you will get the same result. Finally, compute 5, choose 1, 2, 3, 4, 5, 6, 7, 8, and 9. So we are going to create 9 different groups. In each group, we are going to have 1, 2, 3, 4, 5, 6, 7, 8, and 9 objects respectively. In how many different ways we can do that? So we can simply do that calculation by m choose 1 to 9. So we can introduce this vector like this, and that is going to be 6.5 10 to the power 34. Okay, this is going to be the end of our tutorial for the first chapter. I will see you in the next chapter videos.